Good evening, everyone. I hope you're well. I hope you hear me well. I'm always playing with the microphone to get a better sound. My computer makes a lot of noise running the software to live stream, so that's the humming you hear. So let me know if you hear me loud and clear, if you hear an echo. Hi, everyone. Not everyone, but whoever's here so far. So, just going to set something up here. All right, I want to show you these notes, and we're going to go through and you're going to tell me where you have difficulty. So I expected you by today to watch the videos, the pre-recorded, edited videos. And these are the notes that you should have from the website, right? Hello. My record shows there's 15 of you so far. I'm going to wait a little longer. It's a little bit blurry, right? So if it's blurry, just reload the page. I don't know if that helps. If things are blurry. Okay. So let me give it a few more minutes. Well, couple minutes. And thank you for joining me. So how many of you got through all the videos? It's like 2 or 3 hours of videos there for this unit. Good, thank you. Okay, good. So they're not so bad. For some of you, it's going to be reviews. Some of you, it's the first time. But you can go through them again. You can watch them again as you work the exercises. So what I want to do is go through the notes with you and just stop me when, well, I'm just going to really scroll through. Stop me when you want me to review something or you don't feel confident about something. So the notes, what I do in the notes is I introduce the idea of distributions, essentially, how to represent data as a distribution. You put them in order, the numbers in order, and you visualize. You use a graph to begin with, and then based on the graph, you summarize the results. And I talked about stem and leaf plots last class. We did this example together. And then I left you asking you to look at the sample problems document. That's the other GDS document, GDS for graphing and descriptive statistics. And in that document, you'll see the full response and answer solution to this problem. I also take some time to, let me just open that for you. Just opening the document with the sample problem solved. Right, so this is the problem. This is the problem set, and you get this sample problem with Maris and Ruth, and I work out that in the notes and in here as well. This is the one we did in class, the spending data. And then there's a discussion of new com that I think I'm going to mention that when we get to it. And then the hot dog data, which I describe in the notes. There's the data. I just passed through the data. These are the results. What I want to do is just mention the results for the spending data that we did last class. So for the spending data, on page, whatever page this is page 11. So I did show this last class. This is how you summarize the spending data. And then I have the conclusions based on the 5 features and the question. 2 questions were posed. So I worked through the solutions, and the one thing I want to talk about is the additional comments. Do you have comments? Okay, let me talk about this, and then I'll go back to mean and median. Okay, so it says this data is being investigated to show how to handle data with decimals. Here the decimals or cents provide more detail than we care for. If we plot with the cents, we would get stem plots that are too flat, like in the example with the baseball players, revealing no pattern. To make a stem plot of this distribution, we choose to either truncate or round. So we chose to round the data, and we got these results. And I drew the results this way, as a split stem and leaf plot. Right? So this is familiar to you. And I went through the 5 features, and I answered the questions about how you can use this information for marketing strategy. And in the end, I suggested that you can investigate who are these 3 groups. There's 3 peaks. It looks like one here, and one here. And we could talk about the classes associated with that, find out who these people are. Are these actually different kinds of customers with different income levels? Or are they different types of customers, one being bars and restaurants or commercial clients, and the other ones being residential or families, clients, or individuals? And then targeting, finding products to sell to your customers, and maybe if it makes sense to focus more products on these higher spending clients. All right, so that's what we said here with this drawing, but then you could go a little bit back, take some steps back, and ask yourself, why did I draw it like this? Why didn't I draw going like this, going by 10 instead? Now you might have read this document, or just think about it right now. Which stem and leaf plot should I use and why? Which stem and leaf plot should I use and why? The first one or the second one? Okay, second one, and why, Camille? As long as your answer is correct in that it's consistent with the drawing, that's fine with me. So some people said first one. Okay, Liana, because by 10, the data wouldn't be distributed further and it affects the visual representation. I would prefer the first one because it is easier to visualize the data distribution. You guys are touching on the issues. So some say the second one. Okay, so again, as long as you match your explanation with the drawing, I'm happy. And the thing you're going to use is the 5 features. If the 5 features are identical, it doesn't matter which drawing you use. Okay? Let me make that a point. But if they're different, you have to choose. So let's go through it together. Or let's think about it together. There are 5 features. Which ones are the same, or what's different in the 5 features? So the first one is the shape. The shape between the 2 drawings is the same. They both look skewed, right? Right, they're both skewed, but the second one, it doesn't look as skewed as the first one. So that's shape. The second thing was, but in general, they're both skewed. 2, the center. That's going to be the same, right? You're going to use the median because you see they're skewed, so that doesn't change. 3, the spread. The spread, it's still skewed. So you use the 5-number summary and the interquartile range. Because they're skewed. They're both skewed. So that's all the same. Okay, number 4. 4 is gaps and outliers. Is this the same or different? Right, so it's different, right? In the second one, so they are different. since outliers have to be tested, the outliers will be the same because it's the same test, okay? It's the same calculations numerically, but the gap is different, okay? And finally, the peaks, in the first one, there's 3 peaks. Second one has 2 peaks. So I have to choose now, and I have to make a good rationale for choosing. So I'm going to stick with the first one that I introduced you to because it shows detail different from the second one, but not too much. And it captures this, well, I can actually tell you a story about low, middle, and high income earners, or 3 different types of clientele that I can investigate using the first one. In the second one, I don't get that extra detail. It looks like everybody's about in one group, and then there's just a few high, spenders. So I prefer the first story because it proposes a middle class, you know, and a low and high income group something I can investigate. So I choose the storyline and the representation of the first distribution. Do you get that? So in this class, by the end of the class, you should feel more confident about making decisions kind of like this. Like if I give you data or someone gives you data, you have to graphically display it first. And based on that graph, make decisions about the statistics to use. So you're not going to have me around to ask you which one's better, but this is the systematic approach that you can lean on. All right? If the 5 features are different, you got to choose. As long as your storyline matches your drawing and is different from the other drawings, because there might be more than just 2, then that's fine. As long as you have a storyline that matches. There are no right answers, I guess I could say. There's better and worse answers. But yeah, in this case, you guys could argue for the second one because you wanted to investigate different things. You do think it's simply just in one extreme, the 2 clientele. You have if you believe it's the retail customers and then residential customers, you know, so you just think you think it's like commercial, like other businesses buying products versus residences, households buying products, then you can just go with the second one. Okay, any questions about that? So I'm going to go back to the notes. Exactly, Ileana. That's right. Correct. As long as the rationale behind the decision logically connects to the representation of the data and is based on the need for the type of investigation wanted, it can be acceptable. Exactly. And that might be too much for you guys to handle right now, but hopefully by the end of the course you can make executive decisions like that. Okay. So let's continue with the notes. So I mentioned some things here about histogram. There's just some guidelines to making histograms. Did have a video on histograms, I think. Box plots, I teach you how to draw those. We discuss time plots and scatter plots. So those are the drawings, those are the kinds of graphs I focus on. I don't focus on an ogive, but you can look that up. It's nothing I'm going to test you on. It's just another kind of a plot. So here's the discussion I had about shape. The shape. So I mentioned in a symmetric distribution, and we understand that under this curve, in the middle, I need to open, I think I need to open the data, the page. Hold on a second. Okay, so I can manipulate this better. All right. Oh yeah, this is the one I used. Okay, so here we are. So what you have is in the middle, a symmetric distribution. Underneath this curve, sorry, let me get a pen. So underneath this curve, we know there is data, right? There are data, and we put them in order and then put the curve on its side. So you can imagine a stem and leaf plot under there, or a histogram, a bar chart under there. And what we see is that most of the observation or the modal class is at A. Okay, there's a group of observations that we consider the same, but we count them, right? We list them going up. So that is the center, the expected value. It happens that the modal class is in the same place where you're going to find the median, that is where half of the data is on the left of it and half is on the right of it. And it's the same place where you're going to find the mean, the balancing point. So that's all in the same place. So because they're all in the same place, we could use any of those measures to identify the center of the distribution. But the convention is, in statistics, to use the mean. But really, the mean, median, and mode should be about the same number. Well, the mode is not a single value, but the modal class should, basically the mean, median should be inside the modal class. Modal class is where the class with the most observations. So examples of symmetric data include things in nature, height and weight of adults, and so biological phenomena also, it turns out that stock market returns are symmetrically distributed over a long period of time. So not just for an individual stock, but for a portfolio of stock. Okay, so this stuff, there's many applications in finance and in biological sciences, as well as obviously anything that uses statistics. So that is the symmetric distribution. And then we have distributions that are not symmetric. They're either with some extreme high values, right? Few extreme large values, and some distributions have a few extreme small values. And then I provide some examples of that. It's often the case that income is right skewed with a few large values, right? You always hear about the 1%, for instance, the billion, like the trillionaires or the multi-billionaires, let's say it like that. The individuals. So if you look at income of households, there's just a few households that are making a lot of money, very different from the rest of people. So often when you hear about income statistics, you hear about medians. Median income are reported or discussed. Yeah, your page is blurry. My page is not blurry. You have to refresh your page. Just let you know. It will work. Because mine's not blurry. It's a personal thing on your end. Okay, so what do I say? So income is right skewed, just a few high values. And then for left skewed, just a few small values. I use the example of grades, school grade completed. Very few people have, at age 18, have no education or very little education. So they would be over here. And most other people would be over here. So that's a left skewed distribution. So the other thing to talk about is, okay, so what's the relationship in skewed distributions? What's the relationship between these measures of center? So I explained to you always that this one here, or we can talk about C. This is the mode here, right? It's the modal class. And then this one here is the modal class in here. It's the group, the class that has the most observations. It gives a peak. But we just call it the mode. I lost my D. Okay. And then it happens that where the distribution is left or right skewed, the mean is pulled closer to the tail than the mode, of course. And that's because the mean uses every single value to calculate. Remember, the mean is just the average. It's all the numbers divided by how many there are. So these extreme values over here and here go into your calculation. So that's why it's affected by those extreme values. And it drags the balancing point of the distribution over to where the tail is. Leaving in the middle here leaving in the middle of the mean and the mode another line, and that turns out to be always the median. The median is like, it's always going to be calculated. I'm going to have to do that using my typewriter. The median is always in the middle of those numbers. It turns out the median is the position where you have 50% of the observations on the left and 50% on the right. It doesn't care about density. It doesn't care. In other words, the balancing point is the mean, right? This is the balancing point. It needs to, the balancing point needs to balance that distribution on a pin. So that's going to be pulled towards this tail. The median, however, is where 50%, half of the data on the left, half on the right. That's different. If you put all the data in order and you find the one in the middle, this is what we looked at the other day, last week, the median turns out to be different than the mean. And I left that exercise for you to calculate the mean in Excel or using your calculators. All right. Any more questions about that? So there's questions like that in the quizzes and in the notes and in the tests. So is there any comments about this? I'm not going to test you in the geometric mean, but I just mentioned it here because in finance you use the geometric mean for rates of return. To find the average rate of return, you would use the geometric mean. And I'm not going to get into it unless you have questions. It's just another application. I'm not going to test you on that. So spread. Any questions about volatility? You have to tell me, or I'm going to continue. So we did do the 5-number summary calculation, so I recommend you read the notes, watch the videos, make the calculations, and remember the concluding remarks in boxes. If the data are symmetric, you should use the mean and standard deviation. If they're not symmetric, then you should use the median in the 5-number summary and the IQR for the spread. Okay, stop me if you want me to stop to talk about anything. Is there anything? Page 7. So when I put this heading in, these are where the videos are, where you can find them in order in the playlist. No comments, no questions? Okay, then I take some time here and I make a video all about the mean and the median. And I talk about the spread, known as the standard deviation. So I'm going to ask you, if you haven't watched it, to watch this video because it takes about half an hour to go through this in detail, or 20 minutes. So you need to have watched this video. What I want to do, I did do this last class. Oh, these are not the annotated notes. I should show you the annotated notes. Right. So I made this calculation step by step, and I explained this formula. I really don't want to go through this again because the video's there. What I want to do right now is show you or demonstrate how to get this number on your calculator. So, so you do need to come to class prepared. I'm going to put the calculator on the screen. I guess I have to make it really small to fit it in. So what we're going to do is use the stat mode in this calculator. I think I did it last time, but maybe it wasn't so clear. I felt like we didn't look at it together. I recall. Oh, I lost my image. So what we're going to do is put the original data into the calculator. And quickly calculate the mean and the standard deviation. Okay, so I do want you to know this theory that's outlined in the notes, and I want you to watch the video associated with it, and understand the nature of this formula, where it comes from. But really, feasibly, it's intractable to do that every time. You're going to use your calculator instead, right? Unless I ask you to use a table or work it all out by hand. I expect you to use the calculator and calculate this efficiently. So what you do is you put your calculator into stat mode. You see I have some numbers there already. I have some data already in there. And for this data, Camila's asking if they are not, I'm not sure what your question is, but maybe you don't calculate, you shouldn't be calculating the mean standard deviation and interpreting it if the data are not symmetric. Okay, you would use the 5-number summary for that. So what we do is hit second and data to put the numbers in. Now I already have numbers there. I need to erase this, right? So I say second, clear work to erase the worksheet. So you have to be in the sheet to erase it. Now that I'm there and I erase it and it's clear, it should be clear. There you go. And now I'm going to put the numbers in. So I hit the number and I hit enter and then down, and there's just one value, so I just keep on going. I skip over the second variable y. The next observation is 8, enter, down, down, and the next one is 10, enter, down, down, and the next one is 16, enter, down, down, and the next one is 5, enter, down, down, and that's it. So now I ask the calculator for second and stat. And here's my output, my results. For linear data, well, the calculator is meant for, it's set up to be able to calculate statistics for two variables and relationship between two variables that are linear. So that's what lin means. And when you go down, there's 5 observations. X bar is $8.20, correct? And then this is Sx, and this is sigma x. And then it goes into the y's. And we'll talk about this more when we get to doing two variable statistics. So I have to go back. Oop, no, I have to do it again. Second stat. Clear. Second stat. There's my results. Okay, so I want to ask you now, what is this, Sx, and what is this? So what's Sx? So really in this class, you're going to learn how to interpret results. You need to know what these mean. Okay, so Sx, you guys are close, is the sample standard deviation. Sx is the sample standard deviation. So what is the other thing? The other thing, this one is called sigma x. I can't put the symbol on here. So sigma x. Sigma x is what? I'm going to turn off my what's sigma x? Very good, Hector. It's the population standard deviation. So let's look at these in practical terms and what is the difference between them. What's between the difference between the standard sample and the population? What's the difference? What am I asking? Which one's bigger? Which one is bigger? Yes, the sample is taken from the whole. You guys aren't watching all the videos, hey? You guys gotta watch all the videos. This is not gonna work. Okay, population would be bigger. You guys are interesting answers. Very good. So The sample standard deviation is bigger, you see? So which one should I use? So I have two questions. One is, I have many questions actually, but okay, so which one should I use in this problem? Should I use this one or should I use this one? Thank you, Jorge, that's true. Jorge says the population standard deviation is a parameter which is a fixed value calculated from every individual in the population. A sample standard deviation is a statistic. Okay, so my question was, which one should I use for this problem? Anybody else? Okay, very good. So yes, you get it. So you know it's the sample one. So the calculator doesn't know what you're doing, right? Neither would a computer. You have to pick the right statistic. All the time, you have to pick the right statistics. It's just a calculator. It's just punching out, you know, using formula and turning out numbers. You have to know which one to use. So this is the one. This is the sample value, sample standard deviation, or the statistic, right? This is the statistic. It's calculated from the sample. So the other one, well, it will always be, well, okay, no, that's the question. Will it always be higher than the population standard deviation, or is this just a coincidence? Will the sample standard deviation always be higher than the population standard deviation for any data set? Well, let me be clear. Using this data set, the calculation, so it's the same data set, okay? The question is the interpretation of the result. Is the result that you're looking for the sample standard deviation or the population standard deviation? You told me for this one it was the sample, and you're correct. The next question is, if you do it this way for any data set, where you interpret it either as a sample or the population, will the sample always be bigger? So we saw that the sample standard deviation is bigger than the population standard deviation for a data set. Obviously, if you had more data, you couldn't make this. I couldn't ask this question if one one calculation was based on a different data set. So what I'm going to do to make my point is turn this calculator off. So basically what you have here is This is the sample standard deviation formula. The population standard deviation formula I write on the next page, and it looks similar, but it's different. What's different is going to be this and this. Also this, the symbols. So if I interpret this data set here as this was the population, I said, oh, well, this is all the data there are. There's nothing else. It's not just a weekly, it's not just a sample. So this was a sample from a week of pocket money that a person had. And, you know, the pocket money that a student has, I guess, would be an any day, could be any day over her whole degree, right, if it's a student. So that would be the population. Or if you target population was the year of data you could have collected when she's on campus with money in her pocket. I just looked at a week, so this is a sample. But if you said that's all I want to study, that's all I cared about this particular week and these particular daughters, and I said this was the population, then I would have to calculate this where n is the size of the population. And what I do is calculate what's called the average of the squared deviations from the mean. And I use a capital here. And then, what do I write next? Does anybody know? What I write next explains a lot. Which mean, Jorge? Jasmine's very good. Mu. So which mean is that? Everybody else? Nope, not mean squared. Which mean? What kind of mean? So this mean is called the sample mean. What do I call this mean that I'm going to put here? Very good, Hector, with a question mark. The population mean. Okay? So that is actually the only thing that changes. There are three things that change. I use a capital X because this is the notation for actual values that are fixed and known. This is the population mean. And because I use the population mean, when I calculate the average, I use the actual population size, n. So this is the average of the squared deviations from the mean. It's giving me an idea of how spread out the values are. It's because I don't have this, I don't have mu, that I have to use X bar instead, and because I put an estimate inside of an estimate, so I put a sample mean inside of the sample standard deviation, that affects things. That affects things, and the adjustment to correct for it is to reduce the denominator by 1. Okay, so let me go back and explain what's going on. So because I had to use an estimate, X bar, instead of the population mean, because I don't have it, this number, X bar, what it does is it it ties all the other numbers together. By doing that, you lose what we call a degree of randomness. Otherwise, the values over here, they all introduce 1 degree of randomness, and so there's n degrees of freedom. We divide by n for the average to deal with the randomness of the variable. Over here, we lose a degree of freedom because we tied all the values together in this one calculation. What it results in doing, what the consequences are that if statisticians went ahead and they treated if they actually test this and they say, okay, we're going to make up a population and then we're going to sample from that population. What we're going to test is S. We're going to create a sample and then calculate the S. And then we're going to draw another sample and calculate S. And draw another sample and calculate S. So they're going to have like S calculated for samples, simple random sample. So this is the idea of repeat sampling. So they're going to have simple random sample 1, 2, 3, and they're going to just calculate S and S. In our case, we got the standard deviation ends up being $5.31 for the sample we got, right? But we could have had another sample and it could have been another standard deviation. It turns out if statisticians do this empirical study, it turns out that the average of the standard deviations, the sample standard deviations, will not be let's say they should be we're going to talk about this more in Unit 5, but for now I need to tell you this now, and I'm not going to test you on this, but it helps you understand what we're doing, and we do it a lot. Hope you can read that. I should probably just type it. I'm going to type it. Sorry, I didn't get my iPad yet. Should be next week. I have my new iPad. Okay, so the average of these S's should be, so if I took all of those and I calculated the average, I should get the true standard deviation on average. And it will work if I do this. If I divide by n minus 1 rather than n. If I divide by 5, because that's what the n was here, it won't work. It tends to be too low. So what this accomplishes is it makes it bigger, okay? It makes it bigger. So doing it this way, if you assumed you had the population, realize you're dividing by a bigger number, so sigma ends up being lower. So we divide by a little bit of a smaller number, minus 1, and it ends up being bigger. So the point is, if we don't do something, we're going to have what's called a bias estimator, because it's going to be off. We need this on average. Our sample standard deviation should look like the real standard deviation, the population standard deviation, and it won't work. So to compensate, what are we doing? We're trying to get a spread, and I'm going to go through the interpretation now with the statistics. I'm trying to get a spread. How spread out are the numbers? If you go a little bit higher, you're going to be sure to cover all of the data. So that's why that's my layman's explanation for this, but in general, in statistical terms, there's a rationale for this that goes beyond that, and it has to do with the error that it creates if we don't make this adjustment. Okay, so all I'm saying is that this formula for S is based on the best we can do to get this without having the real parameter mu. So it looks the same, it has the same pattern, it's the average of the squared deviations from the mean. I explain in this video why we square. Please watch this video and realize that the estimate is really derived from the parameter, the pattern for the parameter. Okay. All right, so any questions? Watch the video and then watch this one again, if that helps. So what we do here is we end up with, in our calculator, that was the most important thing I wanted to show you, was how to get it out of your calculator. And now the interpretation. The interpretation is, what do I do with these numbers? How do I interpret these numbers? So this is my answer to the question. The question was, how much does a student spend? How much can she expect to have in her pocket in a given week for spending? That was the question, and my answer is like this. She spends about $8.20 a day, give or take $5.31. We can say that because the data we see here is roughly symmetric. So it's only 5 values, but we can assume symmetry. We'll assume that if you put these in order and you had maybe a few more weeks, we're assuming symmetry. That's really important that you realize you can only make a calculation of the mean and standard deviation if you assume symmetry. It's hard to assume that when you only have 5 values, but if we had more data, we think it'd just be symmetric. So she spends about $8.20 a day, give or take $5.31. You can see that she has the lowest value is 2 and the other one is 16. The highest value is 16, and in between there you have, this ends up being the average, right? And then you have some values beyond that. So if you were to rank those in order, you would have 8 in the middle, and then 10 and 5, and then 2 and 16, and they're kind of equally spread out. So it's safe to make that assumption. So you have, see, it's kind of balanced because this is the middle, and you have, so it looks like 8 is the median, and it turns out to also be the mean. So it's not exactly the mean, but it's pretty close. So when the mean and the median are the same, you can use that as a rationale for symmetry. They're roughly the same in this case. I'm going to put 3 bars. Okay, the mean and the median are about the same. Yes, and Hector is just adding as the sample size approaches the population size. So if you have larger and larger sample, S and sigma are about the same thing anyways. That's another point to make. All right, so let's check out this idea about spread. So tell me what this means. Give me a way of understanding this, give or take. How do I use those numbers? So $8.20. I don't know how to change the pen color on this. So it's $8.20 plus or minus $5.31. That is what I mean. So make an interval to show me the lower and the upper bound of that interval. Right, Leanna. 289 and 1351. Very good. Now, looking at, so everybody gets that? So how many of the observations fall in this range? How descriptive is this interval? Does 2 fall in that range? Nope. 8 does. 10 does. 16 does. Oh no, it doesn't. Sorry. And 5 does. So this is called within one standard deviation. It's the sample mean, right? Within one standard deviation of the sample mean, how many of the observations are in that interval? What percentage of observations? So when you write this, when you write a statement like $8.20, give or take 531, you're speaking about the majority of the data in the middle, but you're not speaking about all of the data. Okay, and it usually will be the case that just one standard deviation when data are symmetric will give you the majority of the data. So that's 60%. What about 2 standard deviations? Make an interval for 2 standard deviations. What do you get? So that would be $8.20 plus or minus 2 times 531. I'll give you some time. Make me the interval. Move. Make that interval for me. Very good. So you guys get the hang of this. So this is going to be, so you have to multiply 2 times 531, and what you end up getting is an interval that is, some of you guys are debating the negative sign, 242, 218, 18, 82. So this is the interval mathematically. And so that's 2 standard deviations from the mean. And in this case, all of the data falls in 2 standard deviations. So by using the mean and standard deviation this way, we can describe the distribution, or we can tell somebody, and someone who knows how to interpret statistics knows how spread out the numbers are, right? Most of them will be, most of the observations, more than 50%, will be within 1 standard deviation. And then, depending on the numbers, you'd have to go 2 or 3. If it's a very spread out distribution, you might have to go 3 standard deviations. Okay, so if you guys are kind of struggling, thinking, oh, I've heard this before, what is this? Clearly, this is not a normal distribution. So this data doesn't follow a normal distribution. A normal distribution is something we're going to talk about. If we have time today, we're going to start with it, or I'm going to leave off. You're going to study the normal distribution this week. But a normal distribution has the pattern that 68%, okay, first of all, it's symmetric. And the pattern is that 68% of the observations are within 1 standard deviation, 95% of the observations are within 2 standard deviations, and 99.7% of the observation are within 3 standard deviations. So this is clearly not normal. Did I write that right? Not. This is not normally distributed, because that would have to be, there would have to be something left in the tails. Okay, any questions about this? I'm going to go on and I'm going to talk about this again in a bit. Okay, I'm going to move forward. And I have this summary here I want to talk about. Do you want to take a 5-minute break? Oh, Jasmine was making a point about the pocket money. Sure, but mathematically it goes to the negatives, but yeah. Pocket money is not negative in this example, if you want to be precise about interpretation. But mathematically, it becomes negative. Statistically, no. Okay, 5 minutes break. Get some water, check your email, text, find your notes, whatever it is. Get your calculator. My 5-minute break became a 10-minute break. Is everybody still here? Okay. So let's just review parameters and statistics. Parameter is the characteristic of a population that we want to estimate. Basically, this is what we really want. So if we're talking about I use height as an example. If we're talking about height, or we're talking about sales, or we're talking about returns, we want to know, if we had all of the data possible, we want to know the average if the data are symmetric. So we want to know this number. We want to know the population mean. In the absence of the population data, we collect a sample and we compute the estimate of the population mean, called the sample mean. We use the symbol. This is a universal symbol for sample mean. It means in different countries they use the same symbol. So you'll see the symbol like on a calculator, you'll see the symbol in textbooks, and so that means sample mean. To remember this terminology, for a population, the numbers computed from a population of data are parameters. A number computed from a sample of data are statistics. P with P and S with S, okay? In Spanish, is it the same? Sample is muestra, so that kind of wrecks my mnemonic tool, but anyway, you guys know English well enough to know what I'm talking about. Okay? Similarly, if I wanted a measure of spread for a symmetric distribution, I would use sigma if I had all the data, but in its absence, the next best thing is to use the sample standard deviation. After that, I go through this discussion, similar, I mean, it's a more long-winded explanation of the one I just gave you when we talked about the formula, where this one comes from. This one for the sample really comes from this one for the population. And because we don't have the population mean, if we only have a sample, we make a substitution using the sample mean, but then a correction for the fact that our estimate will be biased in repeated sampling. It won't be correct if we don't do that. Okay? The S will not be sigma on average in all possible samples. Okay, so this is 2 pages of discussion about this stuff. I'll never test you on it. It's just to give you some background of the formula. All right, I also make a point here that this is the symbol for S, sample standard deviation, but if anyone ever mentions variance, then you have to square the S. The reason why we like this S, or the square root, is because this is in the units. I'm just getting my typewriter. These measures are in the units of the variable, but these ones are the squared values. So we usually have to go from these and take the square root. So watch the video. You need the video. You don't have the complete course otherwise. So from sample variance, we calculate the sample standard deviation. If we had the population, all of the data, the population variance, you take the square root to get the population standard deviation. So we take a square root in each case. Okay. Next, I talk about percentile. So when the data are not symmetric, they're skewed, and you have to compute different measures for spread, and I talk about how to do that. So you should know how to do that. And then I say there's a video. So all the rest is like videos. This has videos, this discussion of the 5-number summary, and box plots. So please watch those. If you have any, I'm not going to reteach this right now, watch these videos, but if you have a question about those, you can ask me. I mean, I spent hours making them. They're going to be better than anything I can do here. They're more refined. All right. So, okay, so I want to make a point about this. Okay, any questions of anything up to here? Okay, thanks for saying so, Leanna. Okay, so this is an explanation. Up until here, it's all the discussion of how you identify outliers if the data are skewed. If you didn't watch those videos, watch those. What do you do if data are symmetric? Can you have outliers? It turns out that we use this rule for symmetric data. If you go 3 standard deviations outside a data set and you find observations, if the data are symmetric, you can do that. Those observations outside 3 standard deviations are called outliers. Okay? So, the pocket money data was symmetric. If you go 3 standard deviation outside, you get this number, right? Again, the negatives, but you just use it numerically. So there's nothing out there, and there's nothing out of this interval at all, either on the left side or the right side. So since all the values in the sample are within this interval, then there are no statistical outliers. Okay? So you got to remember the difference. That's why you really need the shape. You really need to draw it, depict it, or use that rule that I mentioned. If the mean and standard deviation are the same, you can say you can assume the data are symmetric. Okay, so that's the rule. So this is saying basically if data are symmetric but really flat, it's possible that the data has outliers. I see it's not very nice for me to draw on here, but you get the point, right? Okay, we call those statistical outliers. To distinguish it from just extreme values, we actually have a rule for our outliers. Okay. Okay, so then I have a discussion here about box plots. You should watch it if you didn't watch it. And you can ask me next class. Don't be shy to ask me later if we have to go back, because I do want to answer all your questions. But I answer everything there. And then I finish the discussion. This is ogive are not required. You can look that up if you want. It's just another kind of a plot. And then I talk about these examples in the videos, and I solve all of this. Ooh, this is the weighted mean, the weighted standard deviation, and you should watch these videos. This is like my most watched videos. It has thousands of views. I think it went viral. Anyway, watch it. It's important. And it's going to come up again. And I solve this. So everywhere there's a notation, tinyurl.com, that's me reminding you there's a video on that. Okay. And all of this has a video too, I believe. Let me double check. This is page 28. Let me double check. Yeah. I'm just going through the videos to remind myself I did this. Okay, so you can watch all that stuff. And then you can ask me next class if you don't have questions now. So let me know if you have any questions. What I want to do is spend some time solving some problems with you. I do all of this stuff in videos. I'm scrolling. Okay, so any questions? I'm going to flash up some questions for you. Now you can screenshot these problems, because if you don't, come across them somewhere else, it'd be nice to have them. So these questions are from old midterms, and I'd like to practice them with you. So we'll practice them together, and then, so it's 8 o'clock. So yeah, let's do this for about 45 minutes. We can do like 5 problems or something like that. So you're going to have several midterms, right? Several tests. I'm going to refer to them as test 1, 2, and 3. Okay, any questions? Or can I go to this? Test you. Yes, you can use Excel in exams, Jorge. It's fine. You just can't use a human being. You can use your resources. How am I going to post this question? Let me think. Maybe I'll have 2 screens up. I'm just preparing to show you this problem. I'm making a mess. Okay, I want to make those there. And then this one. I lost my images. Okay, I'm going to put this in this corner, and then I'm going to put these above. Okay, so that's your frequency distribution, and those are your questions, are the options, which you can't see. I'll put them down. Okay, so based on that frequency distribution, how do you answer that question? No, these are old midterm questions. So what I suggest you do, well, see, I have a whole bunch of midterms in Moodle, and you can go through those to practice. Obviously, you're going to have to distinguish between the questions for test for the first test and the second test. So the first test is going to be on units 1 and 2. So we're almost like with what we do today. I just have to teach you the normal distribution, and you can answer all those questions. So most of the questions you can answer on the midterm. So go to the midterm problems and solve those. For now, I suggest just take a screenshot of this question so you can remember it and you don't have to dig for it. Okay, so take a screenshot if you know how to do that, hopefully. Okay, so let's see if you can answer the question. Yeah, give me your answers and then we'll discuss. So everyone, try to do it yourself. I should actually say don't answer it right now. Let's take a couple of minutes. Maybe I will, Okay, yeah, if you're done, just hold on to your answer. So let me give it a couple of minutes, see who can get this. I'll come back and ask you for the answers. So what you get here is like a information for a histogram, really. You get the class. You get the class, right? These are just classes. And then these are the frequencies here. That's what a histogram is. Let's we're going to look at histogram. I'm just double checking that I have a video for that. No, we're gonna have to do that together, I believe. Okay. So this is like this will give you a histogram. It will give you the height of each bar for the different classes. So what you have are most of the observations are here, right? And then you have just a few petering out over here, spread out. So so this is at a balance, right? This is not most of the observations in the middle, some left of center, and just as many right of center, and then some very extreme low, and then some very, it's not like that. So this is skewed. So because it's skewed, now we have to decide, is it right or left skewed? Is it right or left skewed? Okay, so there's just a few very high numbers here, and that's how you decide. There's a few high ones, so that's right skewed because that's right on a number line. Now it's confusing, I guess, because it's going down rather than up. You guys aren't seeing my notation, hey? How do I get a pen? Oh, here we go. Can you see that? Wait, I got a pen. So here there's just a few on the right, if you think of this as a number line. Going horizontal, even though it's vertical. Is that okay? So it's right skewed. So it's right skewed. So what does that mean? Skewed to the right. So it's either A or C. And then what happens if it's right skewed? It means that the average or the mean is closer to the right tail. The mode (1 minute or 1:30 seconds). So the mode, oh, this is really small. So the mode is here, right? This is the modal class. This has the most observations. And then the mean will be higher. I don't know exactly where it is right now because I didn't calculate it. But that's really small. But the mean would be here, higher than what's in between would be the median. Let's calculate the median. Do you know how to calculate the median? It's not asking for that, but do you know how to calculate it? So you don't have to calculate these things. But let's do it for practice, because the rule will always hold. This was not a great idea. I'm using the screenshot. The median should be here somewhere, and the mean should be the balancing point of the distribution. So let's see if we can calculate the median and mean. You guys go ahead and do it. Even though the question doesn't require it, the answer would actually be, without calculations, you can't see that, can you? All I can do is make it bigger here. That's what I'm going to do. Okay. for now. So our answer is that it's skewed to the right, and the median skewed to the right, so the median is less than the mean. C is the answer. But if I ask you to calculate the mean and the median, do you know how to do it? That's my next question. So let's see, Hector did something. So there's 82 observations. So he counted up how many there were. There are 82 observations. He added 1 and divided by 2 to find where the median was. And that means the median turns out to be in the 41.5 fifth position. So what you have to do is count or make note you can do this you can make note of that's 7, right? And then the next one, this is terrible. I'm going to go for let's do it on this one instead. So I'm going to do it here. Okay, so this is 7. And then for the next one, it's 7 plus 15. So I'm going to do like the cumulative. I'm going to add up how many observations. So this would be 22, right, up to there. And then it would be 44. So this is adding up as I go. And the next group will count up to 62. And we keep going, 66, no, 68. Let me know if I make a mistake. And then 73. And 76. Oh, am I almost done? And 78. And 80. So I got 80 observations. Did I make a mistake? Oh, I made it 46. Did I make a mistake? Did I make a mistake? 15. I think I made a mistake here. No, that's 12. 22. So then 22 plus 24 is 46. I did make a mistake. And then, not that one. 46. And 46 and 18 is 54. $64. And 64 and 6 is 70. Correcting all the mistakes. You guys getting this? 78, and then 80, and then 82. So, how's that? Then we find where the middle of 41 and 42 are. So 41 and 42 should be in here. Questions so far? Okay, so get rid of this. So 40, this is up to 46 here. So 41 and 42 are in here. And I don't know exactly what the number is, right? I just know it's in between there. So I know the median is in here. How's that? So that's because you take 82 plus 1 and divide it divide it by 2. When you do that, you get 41.5. So that tells you you find the median between 42 and 43. This means between 42 and 43. So they're both going to be in this class. So that's where you find the median. In terms of the mean, can we calculate the mean? How would you calculate the mean? First of all, did you get the median? Are you guys not seeing my display? Oh my goodness. So I lost something in the, you guys didn't get to see any of my calculations. Okay, let me drop that and drop that. And I got to do something. What do I have to do again? I have to start a new window. I'm trying to remember. Start a new window. Now do you see? I was making these calculations and you couldn't see it. Looks like it froze. There you go. Okay, now the question was, so you got the median, everyone's fine. I don't know exactly what it is, but I know it's in the class 50 to 55. What about the mean? Where's the mean? how would I calculate the mean if this is all the data that I had? And again, we don't have to do it for this problem. We already got the answer. So I do give you instruction on how to do that in the notes. If you go here, I explain it here. If you haven't read it, I understand. You should take a look now because it's relevant. See this? This is page 26 and page 27. I explain approximating the mean and the variance for group data. So if data is in groups or classes, like in the example we had, we were just looking at, what you would do since you don't have the actual values, you don't have the actual values, you just have these these groups, right? So what you have to do is find the midpoint. Use the midpoint as a substitute for each of these. So what's the midpoint of this class? Does anybody know what's the midpoint? It's right in the middle. 40 plus 45 divided by 2. What do you get? Just imagine being in between, in the middle of that interval. All right, so that would be the midpoint. So that's all the way down. The next one would be what? The midpoint would be 47.5 for that group. So what you're supposed to do is use that repeatedly, like in a weighted average. So the weighted average would be the midpoint times the number of observations plus the midpoint times the number of observations and so on. Okay, so you would use the weighted average. The weighted average is also x bar but you're averaging the frequency, that's the formula that I have there, the frequency and the midpoint. Now again, I never asked you to do this. I might I might not even ask you to do this, but in some of the exercises you're asked to try and find it in. Very few exercises, but that's how you would do it. So it's just it's important to know this is the weighted mean. But because of the way the data is, I have to use like a different expression. Yeah. So this is a weighted mean. Any questions? So you have to do this. All the way down. What do you think? What do you get? So this is because I don't have the data. I just have groups. So it's weight times score. Weight times score. That's the formula for the weighted mean. There's videos about this. Should be. So check out the video on it. Anybody got it? You could do that in Excel too. You guys got it. Very nice. So it's an approximation, okay? Let's be clear that this is an approximation, just like it says in the title of these formula. Right? Approximate mean. Because you don't have the data, you're just using the median for every observation. So it is an approximate. So let me make a point about that. So the best we can do is the approximate mean. Is equal to, you guys got 55.5. I'm going to trust you because I never did this. So some students say it's 55.55. Just double check it. It wouldn't make sense because it's going to be higher than the median. The median was over here. And 55.55 would be in the next group, which makes sense. It's a little bit higher, a little bit bigger. Again, it's an approximate, so, but we know by rule, by the properties of means and medians, it will be higher than the median. It might not be in the next class, but it should be higher in the number, in value. All right, that took some time. Very good. So people who didn't get it, work on that. Take a screenshot. And just as a reminder, that was the notes on page 27. Those were the notes on page 27. So see page 27. Okay, very good. Now let's answer part B, the second question. Are you ready for it? I guess not part B. It's question 4. So question 4 says, which interval contains the third quartile of speeds? Can you guys do that? So my advice is when you solve a multiple choice question, don't look at the options. Make the calculation and be sure you're done with it and then look at the options, okay? Because they're tricky. They tend to be tricky. So how do we get the third quartile? Back to this. Okay, I'll give you a bit to try that, and then we'll talk about it. So take a couple minutes to work on it, and then we'll regroup. I'll ask everyone to give me their answer. Any ideas? What do you get? Jorge, you're not supposed to check the options. You're supposed to compute it. I just said that. Okay, so the third quartile is found at the median of the second half of the data. So find the third quartile. The third quartile is at the median So the median cuts the data in two. So I say upper half. I'll call it the upper half. Shoo! Sorry. So the median is in there. Shoo! Sorry, again. Between the 42nd and 43rd, right? So from 43, from the 43rd, what just happened? Sorry about that. So the median of the second half of the data. So halfway between there, how many observations are? So one way to do this would be to renumber everything. Oh, I gotta just delete all this. I want to renumber this, so just for the second half, right? It's a little more easy to understand. So we would start at the 43rd observation. There are exactly 42 observations in each half. Did I just do something wrong? Is it right? Is it 82? My goodness, I have to double check. So halfway, 82 plus 1, 83. 83 divided by 2 is between, I wrote it wrong here, that's why. Between the 41, that's why I'm confused. Between 41 and 42 observation. Anyway, it's still in that class. I just wrote that wrong. Okay, so it's between the 41st and 42nd. So from the 42nd, to the 82nd observation. So each half has 41 observations in it, right? So to find the median of 41, you do the same thing. 41, so n plus 1 Let me do that again. To find the third quartile, it's halfway through 41 observations, the upper 41. So 41 plus 1 divided by 2 is 42, which is an even 21. So the 21st observation from the middle would be the third quartile. So you got to count approximately 21, where a few of them fall in this class, right? Because it's between 41, the 41 and the 42nd, and that leaves you a few. So if you notice, we've got to go through 21. We already went through so this starts at the 42nd. So that leaves 42, 43, 44, 45, 46. So there's 5 in here. There's 5 in here. And then we still got to go for the rest. Five out of 21 leaves 16, so it's going to be in here. It's going to be just in the next group. So I don't know if I explained that well, but you guys think about it for a second. I think the 21st in the second half should be in here. Right, 40, well, it starts at 42 plus 21. There's 41 observations in each half. So the next one will be the 42nd. So if I renumbered these, let me do that. I think maybe that'll help. Hey, these are a little bit challenging, but you're a master's student, so I can challenge you. So here you're going to find one. Okay, so because there's 46 and I only want to go up to 45, that leaves 5 observations in there. And then here there's going to be 18. So you see what I mean? Because there's 5 left. Because I go up to 41, and there's a total of 46, so that leaves 5 more for the upper half, and the next group is 18 that I get from here. Does that explain it? So that's 23, so it's going to fall in here for sure. Okay. think about that and then tell me if that didn't make sense. Maybe you just need to sleep on it. If it stops you from sleeping, let me know. Okay, so this upper half starts at the 42nd observation. The 42nd observation means there's 5 in this class. 42, 43, 44, 45, 46 is 5. And then this one has 18, so I just copied that over there. Okay, so the answer is 55 to 60. Let's see if it's an option. It's A. And if you didn't know how to do this, you would have picked the wrong answer. You do have enough information. Okay, so some people got that. Some people are probably blown away and confused. So just rewatch that video and see how you do. Should we do one more or should I let you go? Okay, it's 8:40. I should probably just let you go. So for next class, I'm going to focus on the normal distribution. What I want you to do in preparation, let me show you first before we go, let me show you the midterm that you can just practice. Maybe you probably want to get through the normal distribution first, but anyway, you could start practicing. I see no harm. You have many problems to do, for sure. So this is these are all the videos, the practice assignments you can try, the quizzes. Oh, these were in-class quizzes, you can try those. And then these are the online quizzes. And then there's the normal unit. There it is here. So you have all these videos. The only thing that's missing is the first page. But I have everything else done. I'm going to search for a video for the first page and I will email it to you. So you can watch that and then watch these. And then I'll get you through all the notes. If you don't have time to watch the whole thing, it's okay. I also want to see if you have any problems with the units before this. So if you do this for next week, that will take us to September 17, and I have the test slated on the 24th. So if you guys can work on this week, then I can spend the class basically preparing you for the first test. So work on all these, and then we are not going to talk about Unit 3 before the test. We'll discuss it after the test. Okay? Where you're going to find the exercises for practice once you get through all the materials are here in the midterms. These are all old midterms for practice. Okay, so you can practice them. Oh, I have lots here. Look, these are more recent. These are harder. So hopefully you can see all of that I just demonstrated. And the thing about these midterms it'll cover the units 1, 2 with the normal distribution, but there's also going to be regression questions. So you can just skip over any questions about regression. What is regression? Like you can do all these problems, see? Box plots and things. I'm going too fast. Normal distribution. All of this. Some of them won't have, some of these tests won't have. Okay, so there was no regression at all. So that's good. So you can do all of these. You should be able to do all these problems. Regression is when you have two variables. But you know, might not even have time to do these. You just be working on the other stuff, and that's just fine. See, these are all problems that you should be able to solve. So for this week, you're going to work on the normal distribution. We'll discuss the normal distribution next class, and we'll do some midterm problems for practice for you. You see this one's here? It says RLS excluded. That means regression least squares is excluded. So sometimes I have it on the midterms and sometimes I don't. Any questions? Were you able to see all that? I just realized the video, the image was distorted. Oh my goodness. My video's all distorted now. There you go. Sorry, Leanna. Okay, so let's do that. I'll send you a video for the first page, and then you guys should be able to get through the normal distribution, Unit 2 normal. So Unit 2 has two sections, right? The graph, the GDS, and then the normal distribution. And that's it. That's for your first test. And the test, I said, would be 1.5 hours. And it's open book. You can use materials. You just can't use human. You can't ask anyone for the answers. I will put it, I'll probably just put the questions into Moodle. I'm thinking of doing that. But I'll let you know next week for sure. So what I'll let you do is, like, you'll answer the Moodle questions. It'll automatically grade it. And then you can upload me your solutions, like your written work. So maybe I can find part marks for some students. Okay, with that, I will say good night. Unless anyone wants to stay back and ask me questions, I will say good night to everybody else. So good night. Good luck reviewing the video that we just did. If it was confusing, I understand that. Just a matter of practice. Good night, Freddie, Hector, Francisco, Edgar. Yeah, and if you have questions over time, remember, you can send them to me, that if there's any way to help you. Just keep a list of your questions, and the beginning of next class I'll answer questions. It's all a matter, it's mostly me answering questions because the lectures are already online. Good night, Maria. Geriat, good night. Irat, is that how I would say it? I can't even. Can't see that small for some reason. And next week I'll have my iPad. I hope that helps. Good night, Marlene. Okay, I'm really going now. No questions. Bye.